And so if you remember at the end of the law of cosines / law of sines quiz, right, at the very end, I gave you guys some like patterns and stuff like that. Hopefully people didn't spend too long, on those, or didn't keep them up at night if they couldn't quite get them. I do have the answers to those though, if you're like interested. Okay, I can show you. If you weren't able to quite figure some of them out, or if you didn't care, that's okay too. But now you want to start caring because this is stuff that will be on the test on Thursday. Okay. So we're going to start with arithmetic sequences and series, something that you should be somewhat familiar with from Algebra 1, I think you guys talked about arithmetic sequences and series. Of course, that was maybe, a year or two ago for you guys, so maybe it's not so fresh in your memory, which is fine. That's fine, okay? But we're going to, kind of refresh your memory here some. All right. So a sequence is just like another word for like a pattern of numbers. Okay, we're going to look at a sequence first, and then we'll talk about what a series is. Okay, a sequence is like a pattern of numbers, right? An arithmetic sequence is a specific kind of pattern of numbers. Okay, it's an arithmetic sequence. Okay. An arithmetic sequence is a sequence of numbers whose difference between consecutive terms is constant. A sequence of numbers whose difference between consecutive terms is constant. Okay, consecutive terms. All right, so let me give you an example of that. Okay, so let's say we've got like 3, 7, 11, 15, and so on and so forth. Keep it on there. Okay. So what's the pattern here? What's happening in this sequence? Here, yeah, Anna? Yeah, we're adding 4 each time. Okay, we're adding 4 each time, right? 3 plus 4 gets us 7, plus another 4 gets us to 11. The plus one more 4 there gets us to 15. And so we can keep adding 4s, and we keep going. Okay? All right. But again, I didn't really talk about adding 4. When we talk about the sequence here, it says a sequence of numbers whose difference between consecutive terms is constant. So what I mean by that, right, is that consecutive terms, like the 3 and the 7, they're consecutive. They're one after the other, right? 7's right after the 3. The difference there is 7 minus 3. Okay? And that difference is called the common difference. Common because it's shared, right? It's in common in the pattern there. So you can do like 7 minus 3, which is equal to then 11 minus the 7 there, which is the same thing as the 15 minus the 11. You can pick any pair of consecutive numbers, and it should be the same amount, and it's equal to that 4. Okay. So it's the common difference between the terms there. Okay. The common difference between the terms. Okay. So that's an important aspect, right? Every arithmetic sequence will have that common difference. Okay. Every arithmetic sequence will have that common difference. Okay. So another thing about sequences, I guess I'll say here, that I want to also just kind of remind you about, is that these terms in this sequence, they're kind of like they have names, or they have a symbol for them. So like 3, since that's the first term, we symbolize that as a sub 1. That's like the first term in the sequence there. And then 7, since it's the second term, that's going to be, surprise, surprise, a sub 2, right? And then a sub 3, and then a sub 4, okay? So all of these have like names. And of course you could say ... up to, like a sub n, right? Where that would just be some like nth kind of a term there in the pattern. Okay. And so of course we could spend some time trying to find, for example, the next term in the pattern, right? We could just add another 4 and say, okay, well 15 plus 4, that's 19. So the fifth term here, right? A sub 5 would be 19. Right, that's just the next term in the pattern. What would a sub 6 have to be? what was that? 23, right? We just, if the fifth term was 19, then the next term in this pattern would add 4, and so we get to 23. Okay. But what about something if we want to find like a sub 100? Right? Do we really want to sit there and spend the time adding 4 over and over and over and over and over again until we get up to the 100th term, right? That can be kind of a lot. Okay. Well, so we have a formula to find a specific term. So to find the nth term, okay, of an arithmetic sequence, to find the nth term of an arithmetic sequence. And this formula is given to you. Okay, this formula will be given to you. So a sub n for that nth term, the one we're trying to find, so in this case it would be a sub 100. Okay, it's equal to the first term, so we're going to name that a sub 1, plus n minus 1 times d. Okay, so that's the formula we can use here. Again, you won't be responsible for memorizing this formula. You'll be given it, but you will need to know how to use it, right? So a sub n stands for the nth term. A sub 1 is the first term of that sequence. N, well, it's just the number of the term. So I'll use like hashtag # number of the term. And then D is, well, what do you think that stands for? It's a common difference. Yeah, it's a common difference. Yeah. D stands for the common difference. And so we're taking that first term, and we're going to take the number of the term that we want, subtract 1, and then multiply by d, the common difference. The idea is we're repeatedly adding that 4, and so it makes sense to use multiplication here, because multiplication is kind of like a repeated addition, right? We're continually adding that same 4. So we'll take just the number 4, the common difference there, and then multiply by how many more terms we need. Okay? So then, to find a sub 100, or the 100th term, that's going to equal our first term. Well, what was the first term in our sequence? 3 plus, okay, what's n? 100, right? Because it's the nth term, and so the n here is 100, so it's going to be 100 minus 1, and then what's our common difference again? 4 in this case, yeah. Okay, and so then when you do that, you're going to get 3 plus 396. Okay. 400 minus 4. I get 399 then. Okay. So nth term, and the 100th term is 99. 399. Okay. So there's the 100th term. And of course, we want to, okay, so that's one way to do it. So if we wanted to find the 500th term or the 1000th term, we could keep going this way. We could also just write an equation for the nth term of the sequence. So we could just like write a generic formula here, okay, using our formula we got, right? So if we just want to find, if we just come up with like an equation for the nth term. So we don't know what term we want. We're just going to use the nth term. So we'll just say a sub n equals, okay, a sub 1, it's still going to be 3 in our current pattern that we have there, plus, in this case, since we don't know what term we're trying to find, the n is going to just remain n. We don't know what term we're trying to find yet. And then our common difference, well, it's still 4, because we're on the same pattern here. And so there's like a generic formula for this particular sequence. For any particular number that you want to find in that sequence, any term that you want to find in the sequence, you you can do that using this formula, which we could simplify it some, right? The 4 can distribute. And so we end up with a sub n equals 4n minus 1. Okay. If we were to graph this using x's and y's, so like an x here and a y here, what would this look like if we graphed it? What would this look like if we graphed it? Again, if like there was an x here and a y here, what would this look like? Y equals 4x minus 1. What would that look like? It'd be linear. It's a line. Yeah. Okay, that's right. Okay. So every line, right, is in a sense, in a certain kind of sense, okay, it's kind of like a linear. Every line has like kind of a sequence within it, right? Okay. Sequence is, or arithmetic sequence, I should say, is a linear relationship. Okay. It's a linear relationship. I mean, technically, we're not finding like, you know, fraction terms. We're not trying to find like the 1.5 term or something like that. So it wouldn't make it would be in a linear relationship, but yeah, we would have dots instead of it would be discontinuous, I guess. Or not discrete instead of continuous. But anyway, so yep, it's just a linear relationship there. Okay, so let's try another one, just to make sure we've got it. Okay, so let's see here. Example, so let's say our directions are to write an equation for the arithmetic sequence okay, and find the 20th term. And find the 20th term. All right. Oops. Zoom out. Let's go. There we go. Okay. So let's see here. Let's say our information that we're given here is a sub 1 equals 5 and d is 4. A sub 1 equals 5 and d equals 4. So in this case, we're not given the pattern, but we're given information about the pattern, right? We're not given the pattern, but we're given information about the pattern. How could we write this pattern out if we wanted to? Where would our pattern start? 5, right? Our first term is 5, so we could say, okay, the pattern is going to be then 5. What will the next number be? 9. And then 13, and so on and so forth, right? Right, because the common difference there is 4. Actually, I wasn't very creative here. I could have come up with a different common difference, but there it is, 4. Okay. All right. So then our formula, well, let's see. We want to write an equation for the arithmetic sequence and then find the 20th term. So we'll say a sub n equals, okay, a sub 1, that's 5, plus, and then we'll just do the generic n first, and then we'll worry about finding the 20th term. So n minus 1 times our common difference of d. So this is kind of nice. It already gives us all the information we need. We don't have to, like, write out the pattern or anything like that. Okay. All right. So there's our formula. You can simplify it again if you want to, you know, distribute the 4 here. So we get 5 plus 4n minus 4, which is then just, you know, 4n plus 1, or 1 plus 4n. Okay. And then, of course, we want to find the 20th term, so we'll do a sub 20 instead of a sub n. I'll just plug the 20. Okay. So it's going to be 81. Okay. And there's our little equation there. Right. I'll accept either one here. You know, again, if you wanted to leave it unsimplified, a sub n equals just there, that's fine. Okay, that's both the equation. But it is helpful to simplify, so, you know, either one's fine there. And then, of course, there's that. Okay. Questions on any of that? Pretty easy. You guys remember this at all from Algebra 1? Not really? No? Okay, all right. I don't know. Again, I'm pretty sure it's something we cover, but maybe it was something you guys had to skip over too. Because I know that Algebra 1's pretty jam-packed. All right, let's try another one here. Let's do a sub 1 equals -4. Okay, and a sub 5 equals 16. A sub 1 equals -4, and a sub 5 equals 16. We want to come up with the equation for the sequence and then also find the 20th term. Okay. So let's plug in what we know here into our formula. We've got a sub n equals, let's see, we know the first term, it's -4, n minus 1, and then times, we don't know our common difference here. We don't know our common difference. How can we find this common difference here? What to do? Any ideas here? How can we find this common difference? Andrew, idea?
Find the difference between -4 and 16, and then divide by 4. Is that the difference between a sub 1 and a sub 5?
Okay, so let's see here. So let me just see. So you said find the difference between this and this. So the 16 minus -4, like that.
Yeah.
And then you said divide that by?
Or you divide by 4, but it'd be 5 minus 1.
5 minus 1, right. So I'm just going to show that just because. Okay, so I see here. Okay, I see. So what we're kind of doing here is finding the total change, right, from -4 to 16, that total change in our pattern, and then how many steps does it take to get that total change, right? From 1 to 5, that's just 4 steps. So Andrew said divide it into 4 equal steps. So get the total change, and then divide by the 4 equal steps there. What does this formula kind of look like? It's basically the slope formula. Again, like we said, it's like a linear relationship here, right? And so this is you can kind of think of this as an x and y coordinate, and you're finding the slope, right? Because the slope on a line is constant. It's actually the common difference. Same kind of idea there. So when we add, we get 20 over 4, and so we get 5 is our common difference. Okay? So very good. And that's one way to find the common difference. Okay? Does anyone have any other ideas about how to find the common difference here? So we have a point here, right? We know that the fifth term is 16, which means then that I could say 16 is equal to -4 plus my n for this to be the 6 for a sub 5 to be 16. I need this to be a 5 here, and then common difference. So you can kind of plug that other point in, 16 in for the term, 5 in for the n value, and then you can solve this way as well. Okay, add the 4 over, you get 20. 5 minus 1 is 4 times d, and then divide both sides by 4, you get d is 5 that way. Okay, so an alternative method there too. Either way is going to be fine. All right, and so we get, for our formula then, whoops, messed up there. A sub n equals -4 plus n minus 1 times 5. Okay, and again, you can distribute the 5 there and combine like terms. So you get a sub n equals 5n minus 9 is what that'll be when you combine like terms there. Okay. And we still have to find the 20th term, right? So a sub 20 will be 5 times 20 minus 9, which will be 91. Okay? So there are 2 answers. All right, questions on any of that? So the questions will be more than just, here's your pattern, come up with a formula, and find the 50th term. Sometimes we'll be given other kinds of information here too that you'll need to then, use that other information to help you solve and find the other pieces. Okay? So that's an arithmetic sequence. sequence. Let me give you guys. Let me see if I have one here for you guys to try. Oh, sure. I'll just make up one here. So let me give you guys one to try here, just to make sure we're good. Okay. So again, I'm going to have you kind of follow the same directions here. Write an equation for the nth term. Okay. And find the, I don't know, 50th term. Or actually, you know what? Find a sub 50. I'll do it that way. Okay. Find the a sub 50. Just find a sub 50. Okay. So let's see here. Let's say that a sub 2 is equal to 10. Okay. And then a sub, let me see here. Let me make sure I do this right. A sub 7 is equal to negative 20. Yeah. Okay. So write an equation for the nth term and find a sub 50 as well. Okay, using that information there. Now this one is different still from the other ones we've done, right? Because in this one you're not given that first term. You're not given that first term. Okay. But you can figure it out. You have enough information there to figure it out. And there's a couple of different ways to go about it, so I'll let you guys rest with that here. Okay. And yes, feel free to use your calculators. Feel free to use your calculators here if you'd like. Okay. trickier, right? We don't have that first term and we don't have the common difference. So what have we done then? All right, so let's take a look here at this. Now, let me do this. All right, so let me kind of zoom in here. So, first thing that might be helpful, first thing we kind of have to figure out, okay, is what that common difference is going to be. Okay, so a couple of ways you can think about this, right? In this situation, because our 2 points, our two kind of like terms that we know are not that far apart, you could kind of just, I kind of drew a little diagram here. It's like, okay, well, the second term is 10. And then we had to go to a sub 3, a sub 4, a sub 5, a sub 6, all the way up to a sub 7. So how many steps is that? 1, 2, 3, 4, 5, right? 5 steps. We have to go a total of negative 30, right? We're going from 10 down to negative 20, so that's a change of negative 30 in 5 steps. So kind of like what Andrew was saying earlier. So negative 30 divided by 5, you get to negative 6 there for the common difference. Okay. Alternative to that, right? You could also use the slope idea here. And again, negative 20 is like the y value minus the net 10 over the term number, 7, minus 2. Okay? And then that divides up again the total kind of like change over then the number of steps. So you get, again, negative 6. Okay? That's another option there. All right? Then when we come down to our formula here, right, a sub n equals a sub 1 plus n minus 1 times the negative 6. We have to figure out what the first term is. All right, figure out the first term. So one way you can do it is just by, adding 6, right, kind of going backwards. If we had to go from here to 10, and we have to subtract 6 for the common difference, right, so we can then add the 6 back to get back. Or you can use your formula, right? Plug in a point that you know. For example, here we know that the second term is 10, so that means that 10 is going to equal the first term plus 2 minus 1, this is the second term, times that negative 6. And then that gives you an equation which allows you to solve for that first term, which is 16. Okay? So then our formula is going to be 16 plus n minus 1 times negative 6, or again, if you distributed it, it would simplify some. It would be negative 6 plus 22, negative 6n plus 22. And then there's your 50th term, negative 278. Okay? So, again, it seems kind of simple, right? We're just adding the same number each time, but you can be asked in a complex, kind of, challenging way there. I mean, I don't think that's necessarily easy. That a sub 2 equals 10, a sub 7 equals negative 20. Okay? But that's the idea. Questions on any of that? Questions on any of that? All right. So, that's a sequence, right? That's a sequence when you have a pattern of numbers, and of course, arithmetic sequence is just, the pattern of numbers, and you're adding the same amount each time. Okay, now, a series, because I also want to talk about an arithmetic series. Okay, slightly different. Okay, it is the sum of a list of numbers. Okay, or the sum of a sequence. The sum of a sequence, if you want to think of it that way, sum of a sequence. Okay? So in other words, right, so a sequence, we have things like a sub 1, comma, a sub 2, comma, a sub 3, comma, dot, 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 so on and so forth, up to, a sub n. Okay? And so on and so forth. A series takes that same list And instead of it being just a list, you're going to add them up. So it'll be a sub 1 plus a sub 2, whoops, I don't know why I put a comma there, a sub 2 plus a sub 3 plus dot 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 plus a sub n plus dot dot dot, so on and so forth. That's a series, okay? That's a series. Okay? And believe it or not, it can get confusing, right? Sometimes it'll give you pause, you like look at like a list of numbers there, and you're like, okay, what is this a sequence or a series? Well, the difference is a sequence just be commas between the numbers, right? Because it's just a list. In the series, you'll see plus between them because you're combining them up. Okay, you're combining those numbers in the pattern there. Okay. All right. Now, this has another notation that we use sometimes when it comes to like showing this sum. Okay. There's another notation to show this, and it's called sigma notation. So this right here is a series, but another way to describe this, rather than imagining trying to write out an infinite number of terms, we can also write this as sigma, which is like almost like a capital M on its side, a Greek letter. Okay, someone just groaned. Okay, sigma. All right, sigma is like the Greek letter in the alphabet that sounds like. Okay, so it's for sum. Okay, sigma, S-I-G-M-A. All right. And so how do we do this? How do we set this up? So sigma, there's going to be two numbers that go with the sigma here. The bottom number, okay, sometimes it's I, sometimes it's J, sometimes it's K, sometimes it's T. Doesn't matter really what variable it is. Okay. That tells you what term number you start with. That tells you what term number you start with. So in this case, we started with term 1, right? Term 1. And then we're going to add up to term n. So add from 1 to n. Add from term 1 up to term n here. What are we adding? Well, that's what goes to the right of the sigma here. So in this case, because we're just adding up a's, it'll be a sub I. Okay. So we're adding from I equals 1 all the way up to n. All right? And I will only be natural numbers. So you're not going to have, I will never be like 1.2. It's going to go, I will be 1, so there's a sub 1. Then I will be 2, so plus a sub 2. Then I will be 3, plus a sub 3, so on and so forth, all the way up to a sub n. And I guess in this case, since we're only adding up to n, I would get rid of this plus dot dot dot. It's just going to add it to a sub n, so we would stop there. Okay? We stop at whatever a sub n would be. Okay? So let me just give you an example of that. So let's say, for example, that we saw this. Okay? In a slightly different version here, let's just say we saw this. The sum from I equals 1 to 100 of I. Okay? Especially since we just learned this notation, it's going to be helpful for you guys to actually write some of these terms out before you start, thinking about what this sum would actually be. Okay? But anyway, so what's going to be the first term in this sequence here? Or sorry, in this series. What's going to be the first term? If we're just adding up I, right, what does I start out to be? It's just going to be 1. Okay? And then plus, what do we do? What's going to be the next number that we add here? The next number for I is what? It's 2, right? Or count up? Yes. And then the next one will be 3. And so on and so forth, all the way up to, what are we adding up to? 100, okay? Because I will be 100 here. Okay, so this is a little bit different. We don't have an actual, some other function here. It's just I that we're adding up, okay? So the term and the term value are all the same thing. So okay, like that. Actually, let me just do the 98 there. There we go. So plus 98 plus 99 plus 100, right? We'll have all those. Okay. So what is the sum from 1 to 100? How do we do this? Okay. So we could type in our calculators, right? 1 plus 2 plus 3 plus 4 plus 5. I mean, we are repeatedly adding here, but we're not adding with the same number each time. We're adding by a different number. First it's 1, then it's 2, then it's 3, then it's 4. Okay, and so legend has it that this was a problem given by a teacher to a group of students, centuries ago, and one student sat there, looked at the problem for like a couple seconds, and then did a little scribble, and then brought the answer up to the paper, brought the answer up to the teacher. So this is before calculators, of course, so the students were having to sit there and do all the addition and stuff like that. And so the teacher was amazed because the teacher was thinking, all right, this will be a way to get the kids to just be busy for a little while, just make them add up from 1 to 100 kind of thing, right? And so, like I said, this particular student, whose last name was Gauss, Gauss, okay, who's a famous mathematician, he rearranged the numbers, and he decided that, okay, well, if we're going to add all these numbers up, if I then rearrange the numbers backwards, okay, and we add these numbers up, so 1 plus 100 is what? 101. What's 2 plus 99? 101. 3 plus 98? 101 plus ... And then we add the 98 again with a 3 in this case, 99 plus the 2, 101, and then the 100 plus the 1, the 101. Okay? So essentially we're adding the sequence together twice. We have it once in the normal direction, we have it once in the backwards direction, but then as a result of doing that, we're able to get the same number. How many 101s are we going to have? 100 of them. Okay? So it's going to be 100 times that 101, but we have to divide by 2 because we add up twice as much, right? We did the original sequence, the original series plus that series again, so it's twice as much as we need, so we'll divide by 2. So I'm just going to multiply by 1/2 out here. Okay? And so then we can just do that much easier, right? And we get 5,050. In fact, that is the sum of that series. That is the sum of that series. And in fact, in general, the formula for an arithmetic series, okay, is n over 2, the number of the terms, times a sub 1 plus a sub n. Okay? N is the number of the term, a sub 1 is the first term, and a sub n is the nth term. Okay? Okay. So I'll just do a quick example here because I know we're running out of time. All right. Do a quick example here. So, just as an example, given the sequence a sub n equals 2n minus 6, okay? So now given that sequence, a sub n equals 2n minus 6. So again, if we were to populate that sequence, right, it would just be commas. The first term would be, what, -3, or -4, I mean, and then so on and so forth. We keep adding 2 there to it, okay? Given this sequence, find the sum, so now we're talking in the series, find the sum of the first 150 terms. Given the sequence a sub n equals 2n minus 6, find the sum of the first 150 terms. Okay? All right, so we want to find this on the first 150 terms. That means we're going to use our arithmetic series formula here, n over 2 times a sub 1 plus a sub n. But of course, what is n? It's going to be 150 here. So it'll be 150 over 2 times All right, a sub 1. What's the first term in this sequence? Negative 6. How'd you get that? Oh, negative 4. Sorry, it's negative 4. Yeah. You get negative 4. Yeah. So this formula here gives you the terms in the sequence, right? So if we want to find the a sub 1, we'll put 1 in for n here. 2 times 1. I'll write that over here. A sub 1 equals 2 times 1 minus 6, and so we get negative 4. So that goes in there. And we want to find the nth term. In this case, we want to find the 150th term, though. So how can we find the 150th term? What can we do there? Yeah? Yeah, put in the same exact equation. Right. A sub 150 equals 2 times 150 minus 6. Okay, which is 300 minus 6, which is then 294. Okay. So in other words, negative 4 is the very first term, all the way down to the last term. The 150th term is 294. You kind of take those numbers, you split them, you rewrite them in, the reverse order, add them up. Okay, just like Gauss did, kind of thing, using this like basically what the formula is doing here. And so we get 150 divided by 2 is 75 times 290. Okay, which when you multiply that out gives you 21,750. Okay. So there it is. Okay. All right. In sigma notation, so again, if you saw this in sigma notation, it would look like this. What did we do here? We did the sum from 1 to the 150th term, from 1 to 150, of 2i minus 6. Okay, we added up this pattern here, 2i minus 6, right? That was the sequence of numbers that we added up. Okay, so 21,750. Okay. Questions on any of that? All right. So let me give you guys your assignment then. Okay, I'm going to change the assignment slightly from what's in the on the calendar again, just because I want to give you an opportunity to practice the sigma notation stuff. So on page 648, okay, I'd like you to try numbers 85 to 89 and numbers 103 odds. Okay. And then on page 657, numbers 5 through 19, 59 to 69, and 91, and those are all odds as well. Okay. And again, this would be calculator active. Use your calculator to help you with these. Okay. Use your calculator to help you. Okay. Okay. Ready for me? All right, great. Thank you. I'll take that. All right. Any set requests for today? Set requests? Yes. Emma, I got you down. Julia, I put you down. Thank you. Okay. Caitlin. All right. Noah. So Jackson, I'm going to put you in too to make that quiz up, right? And Anna, you can come in too, right? Okay, very good. Thank you. All right. And who else did I see? Someone else? No? Okay. Matt, I'll put you into. Okay.